Hi everyone. Here we are on question 4 of this week's practice, the last question of the practice that we have actually on arithmetic and geometric sequences. So on number 3 we looked at geometric sequence and found a specific term of it. In this case we're going to be approaching a question like number 1, but in this case it's geometric. So the geometric end tells us how we move from one term to another in this sequence, and we do so by multiplying. So the third term is 3, the seventh term is 48, and we want to find the common ratio, we want to find the first term, and we'd like to find the 10th term of this sequence. So let's go ahead and do that. So here we have it written out. I'm going to approach this problem a lot like we did number 1. There's a lot of formulas we can memorize and substitute into, but I just like going back to what's happening in this pattern or sequence and writing it out always. So I'm going to start writing this sequence. I don't know what the first term is. We're going to set out to find that eventually, but I'm going to just put a space for that. So here's my first term. I don't know what it is yet. I also don't know what my second term is. I do know my third term is 3. I don't know fourth, fifth, sixth. I do know the seventh is 48. So what we can think about here is how we get from one term to another in this sequence. And because it's geometric, we multiply by r. So to get from the first term to the second, I multiply by r. And I'm just going to keep multiplying by r here, putting that times r into it because it shows us the structure of this and how it's changing. So there we have it filled in with times r times r times r. So now what we'll do is just look at how we get from 3 to 48. Well, if I start at 3, to get to 48, I multiply by r 1, 2, 3, 4 times. So I can write a formula for this. I can say to get to 48, I start at 3, and I multiply by our common ratio 1, 2, 3, 4 times. So 4 r's multiplied there. We'll use the exponent instead of just doing times r times r times r there. Now it isn't a coincidence here that 7 minus 3 is 4. That's another way we could do this shorthand. But I like writing out the structure and seeing the patterns in this because that's what this is all about really. So if I start solving this, divide by 3. 48 divided by 3 gets us 16. And then we have sum r to the 4th power is 16. So we need to ask ourselves what number times itself 4 times is 16. We can approach this like rooting using a radical, so we can take a 4th root of this, which I'll go ahead and do. This just says what number times itself 4 times is 16. We know that's 2. You can raise it to the 1/4 power as well in a calculator, and that will do the same thing for us. So 2 is r. Now before we get too far into this, we need to realize that there's actually, let's mute this, there's actually 2 values of r we can have here because it can be alternating positive, even, positive, negative, positive, negative, positive, negative here. So there's 2 values we can have for r, and that's going to change one of our answers later on down the road. So we can have positive 2 as r, or we can have negative 2 as r. So if we start writing out this sequence and seeing what's happening, well, if I consider the positive 2 version, this is positive 2 here for this sequence. I know that's blocking it. If I want to keep filling in spaces here, well, I can do 3, my third term, times positive 2, which is 6, times positive 2, which is 12, times positive 2, which is 24, 48. And then if I want to move to the left here, oh, sorry, you couldn't see that. I'm going to start dividing by 2. So dividing by 2 gets me 3 halves. Dividing by 2 again gets me 3/4. So here I see my first term is 3/4 of this sequence. So I have that part done already. U1 is 3/4. Now if we consider r being negative 2, you're going to see what happens here. And it's actually pretty cool that there can be 2 values here. This is called an alternator when we start multiplying by a negative number over and over and over again. So if I start at 3 again, I multiply by negative 2 now, I get negative 6. I multiply by negative 2, positive 24. Oh, hold on, let's back up there. Jumping ahead of myself. This would be positive 12. Now multiplied by negative 2, that would be negative 24. Multiplied by negative 2, that would be positive 48. So as you can see here, this times negative 2 actually fills the same pattern that we had. It's because we were given 2 terms which were both odd. They were both the same. Parity is what I was looking for there. Both the same parity, even, odd, odd. This happens sometimes in sequences. So now if we work the other way around, I'm going to start at 3 and divide by negative 2, which gets me negative 3 halves. Divide by negative 2 gets me positive 3/4. So as we can see here, It doesn't matter which sign we chose for r in this case because both of them worked out. U1 is 3/4. I'm sure a lot of you just went with a positive 2 and went on your way. I'm not sure what IB would look for there specifically. So last thing we need to find is we need to find the 10th term of this sequence. Let me pull a new sheet of paper and get this all in one place. So this is number 4 still. What we know right now is we know r is either positive or negative 2. We know the first term of our sequence is 3/4. And in this case, we want to find the 10th term. So we're going to index that as n. We're going to assign n as our number of term we want to find. So just like arithmetic sequences, there's a formula here that does it for us. All it does is it multiplies over and over again. So if I want to find any term of a geometric sequence, I'm going to start at the first term, 3/4. And I'm going to multiply, 3/4. And I'm going to multiply by r. So multiply by 2. Or we're going to have 3/4 times negative 2, and we're going to do this n minus 1 times, just like with the arithmetic problem, because we already have the first term, we don't want to double count that. To get from the first to the second term, I multiply by r 1 time. To get from the first to the 8th term, say I'd multiply by r 7 times. So we're going to multiply n minus 1 times, n minus 1 times, and in this case we want to find it when n is 20. So to find the 20th term of this sequence, I start at 3/4 and I multiply by 2 19 times, or I start at 3/4 and I multiply by negative 2 19 times. So when we go through this, I'm going to throw it into a calculator real quick. 3/4 times 2 to the 19th power. There we have it, right? Oh, that's stretched big time. 2 to the 19th power. There we have it. So 2 ways we'll write this. 3, 9, 3, 2, 1, 6. Or if we're multiplying negative 2, well, this is just going to be the negative version. Negative 3, 9, 3, 2, 1, 6. So this is the standard way we'll write it. If IB calls for 3 sig figs, let's go ahead and write that as well. So that would be first significant figure, second significant figure, third significant figure, and on. Or first significant figure, second significant figure, third significant figure, and zeros out. So there we have it. 2 answers. Again, I wouldn't get so caught up in the negative versus positive r value. We just have to address the fact that there could be 2 answers there along the way. So that does it for this week. Hopefully the 4 videos we posted or I posted made some sense to you and helped you out. Again, send me questions, private messages, or comment on the discussion boards in Google Classroom with other questions you have. Enjoy your weekend.